Today we will analyze the response of an RC circuit when the input is a sawtooth current waveform. Consider an RC circuit. Here the resistor is 1 kilo ohms, capacitor is 500 nanofarads, input current source is a sawtooth with height equal to 10 milliamps and time period is 10 milliseconds. We want to find the voltage across the capacitor. Now at 10 milliseconds, the voltage across capacitor would have charged to 100 volt and the equation used to calculate this can be given as follows: 1 by C integration of IC of t into dt. IC of t is equal to t. Because at 10 milliseconds, the current is 10 milliampere. So 10 milliampere minus 0 divided by 10 milliseconds into t will be equal to t. On substituting that t here, we get voltage across the capacitor to be 100 volts at 10 milliseconds. We can see that at 10 milliseconds, the input current drops to 0 and the current source will be replaced by an open circuit. Since there is no path for the capacitor to discharge, it stays at 100 volts and starts charging when the input current is available again. And the equation can be seen as follows. T start here is 10 milliseconds. Since it is a sawtooth current waveform, if we consider a waveform with time period 10 milliseconds, within 10 milliseconds, the input current keeps changing. And the voltage across capacitor at 20 milliseconds can be calculated as 1 by C into T real will be 20 milliseconds minus T start is 10 milliseconds divided by 2. On substituting the values, we get 100 plus 100 volts is equal to 200 volts. This is the initial voltage that the capacitor had charged at 10 milliseconds. Since there is no path for it to discharge when the input drops to 0, it stays at that voltage level and starts charging when the input current is available again. VR is equal to I in into R and IR is same as input current. Now to capture the precise charging and discharging profile of voltage across capacitor, the calculation is repeated in Excel with time intervals of 200 microseconds. Let's look at that. This is the input that we are feeding to the RC circuit. When time is 0, the current is 0 and the voltage across capacitor is equal to 0. After 200 microseconds, the voltage across capacitor can be calculated as follows: 1 by C into T square by T real square by 2. Now this is how the voltage across capacitor looks like up to 10 milliseconds. Now at 10 milliseconds, the input current drops to 0. Hence, the voltage across capacitor stays at 100 volts. On plotting voltage across capacitor values obtained, we can see this is how the graph looks like. Let's simulate this and check. Now on simulating this, we can see that this is the input current that we are feeding to the RC circuit and the voltage across capacitor can be seen as follows. It is 100 volts at 10 milliseconds and 200 volts at 20 milliseconds. Here is the summary. We can see how the input current has transformed the voltage across the capacitor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for sawtooth current input. Thank you for watching this video.